So in the other videos, I try to explain fundamental quantities, that are the basic quantities, and also the derived quantities. I also went further to classify based on direction, the quantities based on directions. And under that aspect, I classified into scalars and vector. If you don't want to call it scalar, don't panic, just call it scalar quantities, because we know different things have different names normally. Then I also talked about the vector quantities, which have both magnitude and direction. So I also tackled about 4 questions in the other video. So if you have not watched the other video, please I advise you to watch it first before this particular video, because the other video will help you to understand this video. And if you are new to this channel, please subscribe, and if you like the video, click the like button. So I try to tackle your jam pass questions, though I'm following it topic by topic sequentially based on the foundation. But at least I have to answer your past question, because it's not all the areas they set in jam. It was just like when I wrote mine. I wrote mine from secondary school, though I didn't really get up to 300 or so, but I did very well. I think I got to 61. And what helped me was I knew the particular aspect I should focus on. And as far as you follow me, dedicate yourself to studying too, and join my WhatsApp group chat. I promise you that you will do well. So for today's lecture, what I have is calculation of derived units. You know, some derived units, those are the units of the derived quantities, which are every other one apart from the seven that are length, time, mass, the temperature, the amount of substance that's measured in mole, luminous intensity that measure the candela. So apart from those ones, every other one is a derived quantity, because you derive them by simple combination of fundamental quantity, or some even involve simple combination of fundamental quantity and derived quantity too. And the unit is called derived unit. That's what I want to teach you how to derive. For example, now I got this question. Every question I get and solve here is from your jam pass question. I know it's around the corner, but just follow me. I will try to be fast as I can. So calculation of derived units. Question number one, it says of the following derived units, the one that is not a unit of power is A. Joule per second, B. Ampere per volt, C. Ampere square volts, then D. Ohm square per volt, E. Volt square per ohm. So pay attention as I solve. Remove your attention from anything else. Just focus on my solving. So the first thing now is solution. Underline. So when you come across a kind of question like this, I know you don't have time in your exam. I have experienced it, so I know what it takes to get a good grade there. So joule per second, normally when you check power is just kind of, so power is normally what we know from all those SS1 is power equal to work done over time. You know, work done is equal to force times distance over time. And you know that this expression can also be written like this: force times distance over time. And you know that distance over time is velocity. So power equal to force times velocity. Apart from that too, when it comes to electricity, You also find out that power is equal to IV. V equal to I arrow. So when you substitute this V here, you have P equal to I times I arrow equal to I square arrow. Then another thing too is power. Put this one at the back of your mind to help you to be fast while calculating questions on electricity. Though I will create a separate video when it comes to the time for electricity. So power equal to velocity square over resistance arrow. So if you compare, you see that A is here, joule, work done is measured in joule, then time in second. B is ampere per volt. Ampere per volt, that's ampere current over volts. Then C is ampere square volt, which is this. So this is the C now. Then D is ohm square over volt, which is very wrong. With this, you know it's very wrong because what I calculated here was volt square over ohm, not ohm square over volt. So the answer is D. Then hope you understand. There is no magic there. It's just to cancel out the one that doesn't rhyme with all this, because I think these are all the formulas that you need for power. Then the second question says, for which of the following is the derived unit, though that's dimension, ml square t raised to power minus 2, correct? A, moment of a force. Know that moment of a force is torque, which is also work. So when I derive the one for work, I derive the one for moment. Then acceleration is another one that I'm going to derive. So moment is, so this is it now. I was able to derive the dimension of derived units through work. So you get the dimension after calculating the derived unit so that you won't get confused, because it makes it easier by first of all calculating the derived unit, then getting the dimension from the derived unit. So work equal to moment, force times distance, then force is mass times acceleration times distance. Distance is in meter, mass is in kilogram, acceleration in meter per second square. Then when you multiply them together, you get kilogram meter square per second square equal to ml square t raised to power minus 2, because the the quantity that has the derived unit, the unit kilogram is mass, the one that has the 1 meter is length, then the one that has the unit second is time. So that's what dimension has to do. MLT, mass, length and time, apart from some that might include ampere, that's I for current. So when you check I and II, moment and work, they both have this. But acceleration doesn't just follow at all, because acceleration is equal to meter per second, that derived unit. It depends on something though, but that's not the dimension. Meter per second, the quantity that has the unit meter is length, the quantity that has the unit second is time. So L per T, which doesn't follow. So the answer is I and II, which is D. My third question, also from your jam pass question, says which of the following units is equivalent to kilogram meter per second? Kilogram meter per second is the derived unit for moment. Moment equal to mass times velocity. Then also mass in kilogram times velocity in meter per second, which is equal to kilogram meter per second. And we know that change doesn't have any unit. So change in momentum is equal to impulse. And impulse is measured in Newton second, which means the answer is C. Then the fourth question here is, which of the following are the correct SI units of the quantities indicated? I is force for N, then II is torque for Newton per meter, III is power for watt, then IV is momentum for kilogram meter per second square. Looking at it, A is correct because the unit for force is Newton and the unit for torque is Newton meter. It's not Newton per meter, sorry. So I don't think II is not correct. So you cancel it. That's how you cancel out to get your answer. Then power for watt, correct. So this correct. Then kilogram meter per second square for moment is wrong because what I explained in the other question, which is number 3, over here I proved it is kilogram meter per second for moment. So that one is wrong, you cancel out. So what's left is I and I, which is option D. So that's the answer. So I move straight to question 5. Say which of the following quantities has the same unit as watt? Normally, I gave you the formulas. Watt is the unit for power. Power is a derived quantity that has a derived unit. The derived unit I gave you before. So, which of the following quantities has the same unit as the watts? So, its force times velocity is stated directly here, that's option D. Number 6, so which of the following is dimension for pressure? I will solve this since I have not said anything on pressure. So pressure is equal to force over area, which is equal to MA over area, which is a meter square. If it's volume, meter cube, as we all know. Then M mass, M mass, that's in kilogram. Then acceleration in meter per second square, not meter per second, but meter per second square is not velocity. Take note because when you solve wrongly, make a little error, then your answer will still be in the option. So be very careful. Meter square, 1 meter here, cancel 1 meter here, that's this. So it's equal to kilogram. When this meter, there's an invisible one here. So when this meter goes or becomes per meter, then we retain this per second square. And the quantity that has this unit kilogram is mass, the one for meter is length, then the one for second is time. And that goes to option A. So option A is right. You see the way I'm solving it, that's the same way you solve it on your exam day, just that you have to be practicing it repeatedly so that you'll be fast on that day because there's no time. I think you have 2 hours, that's 120 minutes for 180 questions. So what are the other time to write the other 60 questions? You find out that there's no time, so you have to be very fast. Mostly when it comes to calculation in physics, they take time. So number 7, he said the physical quantity that has the same dimension as impulse is what? I've already proved it. This one came in another form, though I've already solved it before, so I will just take it. Momentum is equal to impulse. So unit the same. Change in momentum equal to impulse. Remove that change. Momentum equal to impulse. So I will take B. So that's the way to solve all these questions. You see, I started from question 1 and you saw that there were different formulas, that's for power, which start from work done over time. From there I went forward to force times distance over time equal to force times distance over time. I separated the distance over time. So in some cases you have to separate like this so that you get the formula that you want, because in some cases you have to prove the formula before solving a question. Don't worry, we'll tackle those issues later. Then power equal to IV when it comes to electricity. You see the way I separated it, electricity this side, then all this normal load and everything this side. So P equal to IV, then V equal to IRO. Then when you substitute the value for V, you get I times IR equal to I square R. Then number two, I still prove some formulas to you. Just take time and digest all this information very well. I've gone around the past questions, and it usually comes in the beginning. If you don't see it in the first five questions, it means they didn't set it and they rarely omit it in your jam. So just digest it very well, spend time on it, and also join my WhatsApp group that I will post in this description link. And if you have not subscribed, please subscribe. And if you like this video, click the like button. Thank you very much.